gang, a quick lesson on sketching some very special kinds of lines. And so the activity here says plot the following points. So x coordinate, y coordinate, 2, 4 would go there. 2, 1 go there. 2, 0, 2, -2, and 2, so add 2, -5. Now, if I were to connect these points for like a full graph of a line, that line is vertical. And what would the equation look like for a vertical line? You know? I mean, you don't need to write this down necessarily, but last lesson we were talking about how we could, like, if we knew, well, this is kind of reverse of the last lesson, but you'll understand, I'm sure. If you have the slope and the y-intercept of a line, it'll show up in its equation, you know? Like the equation can show the slope and the y-intercept. Well, take a look at this vertical line. What is its slope, first of all, and what is its y-intercept? You could say, well, is the y-intercept 0? No, 0 is right there. It's almost like the y-intercept doesn't even exist. And you know what? Do you remember about the slope of a vertical line? Like if you figured out the slope, right, like just from like maybe this dot to this dot, you're going down 2 for your rise over 0. That's -2 over 0. You can't divide by 0. So it's almost like this. So your m doesn't exist either. Anyway, so to get to the point, no pun intended, what does an equation of a vertical line look like? Well, what do all these points have in common? In fact, I could make even more points. Like that point, that point, that point, that point, that point, that point. And not only those, that point, 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 that point. All these points have what in common? The fact that x equals 2. So I know it's kind of weird maybe to you right now, but this is actually the full linear equation for this vertical line. In fact, any vertical line will have an equation that is x equals something. You know, x equals some number. Okay, like x equals 5 is a vertical line. X equals -3 is a vertical line. X equals 10 is a vertical line. Okay? And so x equals some number as a linear equation is just a vertical line. Now let's contrast that with this. Plot these following points. -4, 3 is right there. -1, 3 is right there. What's happening here? 0, 3 is right there. 2, 3 is right there. 5, 3. If you make a full connecting the dots graph of like what line contains all these points and then some, what do you think the equation of this line would be? Well, this line is perfectly horizontal where, and again, it's not just these points, that point, 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 that point. Y always equals 3. And so this is the equation, and it's what equations look like for lines that are perfectly horizontal. Always y equals some number. You know, like other examples would be y equals -4, which is, you know, right here. That's that horizontal line. Or y equals 0. That's this horizontal line. Okay? So, and by the way, just as a side note, this type of equation for horizontal lines actually does legitimately turn out that it's in y equals mx plus b form. So like let's look at, so let's highlight this line again. Does this horizontal line have a b value? Does it have a y-intercept? Yeah, 3. So the b value is 3. That's right. The b value is 3. What's the m value? What's the slope of a horizontal line? That's right, it's 0. So in a way, you could write this as y equals 0x plus 3, which this is just kind of gone. So do you see how it fits that it ends up just being y equals 3? But you don't really have to remember that this horizontal line business like actually does go with, you know, y equals mx plus b form, where vertical lines just simply do not, because the slope doesn't exist and the y-intercept doesn't exist either. So here's a neat little summary, you know, trick to remember. Let's use the color, I can't decide. Let's use this color, like maroonish or whatever. I learned this from the great Mr. Birchanowski. It's a memory acronym trick. HOIVUX. So this is for horizontal, and this is for vertical. HOIVUX. So the vertical we learned first was, so this x means that the equation is going to be x equals, you know, some number. And over here with the h for horizontal, the y means that the equation is going to be y equals some number. And even the u and the o, which is actually a 0, spoiler alert, means something. The u means undefined slope, because for a vertical line, the slope is undefined. In other words, it doesn't exist. It doesn't exist, undefined. There is no slope is another way to say it, that there is no slope at all. But yeah, the U stands for undefined slope, and this O is actually a 0 because the slope of a horizontal line is exactly equal to 0. So HOIVUX. So again, just one more time. Horizontal lines have a slope that's equal to 0, and the equations are always just y equals some number. Vertical lines have an undefined slope, and the equations are always just x equals some number. So just introducing this horizontal vertical line business to you in Integrated Math 1. And the rest of this lesson is this. So here we go. A question like this. are the following points on this line. Well, how would you tell? I guess we could graph that line. We could, if we had some nice graph paper, or if we could sketch ourselves a nice grid or XY plane. But that's not the only way to kind of like just, graph this line with that y-intercept and that slope and just look to see if these 4 points are all on that graph. But don't forget, people, that for a point to be on a graph of an equation, it has to solve the equation, okay? Any point that's on a graph is a solution to the equation. So let's see if 1 would be x and 10 could be y together. Let's see if that plugs in to the, so if we plug in the 10 for the y and the 1 for the x, and let's see if that makes the equation make sense, or let's see if it makes it true. Remember, this was y equals 3x plus 7. Let's see if it makes sense if we plug in 1 for x and 10 for y. So does 10 equal 3 times 1 plus 7? Ooh, that's not good handwriting or stupid board. Not all my fault. And yes, 10 does equal 10. So plugging in 1 for x and 10 for y does make the equation true. Let's try 2 comma 9. Let's see if we plug in the 2 for x and the 9 for y. I mean, does the left side equal the right side? And I think you can already kind of see that. Nope. So 2 comma 9 does not solve the equation, and therefore it would not be a point on the graph, on the line. Let's see about this. So if we plug in the 5 for y and the negative 1 for x, does it make the equation true? I don't know. Let's see. 3 times negative 1 is negative 3. Does 5 equal negative 3 plus 7? Well, negative 3 plus 7 is positive 4, I do declare, right? And so, no. That would not be a solution, and therefore not a point on the graph. Well, let's see about negative 2 comma 1. That would be the 1 in for the y, and the negative 2 in for the x, to see if it makes the equation true. So, does it? 3 times negative 2 is negative 6. So does 1 equal negative 6 plus 7? Negative 6 plus 7 is 1. Does 1 equal 1? Yes, it does. So it looked like A and D would be points on the line. And that's how it's done. One more example, I think. How about the following points on y equal 3? Well, this one's, I know this might be weird, but this is actually really easy. If you plugged in these coordinates, I mean, there is no x to plug 1 into, but you could plug in 3 for y, and I it's basically asking, is the y coordinate, 3? Yeah. How about this? Does y equal 3? No. Y, that's a 9. Does y equal 3? Yes. Does y equal 3? No. And it was really that easy. Okay? Because any point on that line, which would be, so hoivux, this would be a horizontal line. Any point on that horizontal line would have to have a y-coordinate of 3. And that's that for 4.2 Part B.